Hello, welcome to RCC's Math Tape 069, Introduction to Equations. In this lesson we will learn to determine whether a given number is a solution of an equation. We will also work with linear equations up through the form AX plus B is equal to C. As you watch the tape, be sure to take your notes carefully. Mark on your paper any place you don't understand so that you can ask for help from your professor or from a tutor or instructor in the math lab. Now let's begin. We have two objectives on this tape. Our first is to determine whether a given number is a solution of an equation. Determine whether a given number is a solution of an equation. Objective 2 is to solve linear equations of the following forms. X plus A is equal to B. AX is equal to B. And AX plus B is equal to C. Let's begin with a definition. An equation is a mathematical sentence in which the verb is equals. An equation has the verb equals. A mathematical sentence in which the verb is equals. Examples: 12 plus 3 is equal to 1/2 times 30. Now notice that 12 plus 3 is 15. 1/2 of 30 is 15. So this equation says that 15 equals 15. That, of course, is true. For our next example, -4 subtract 10 is equal to 5 plus 6. -4 subtract 10 is -14. 5 plus 6 is 11. -14 equals 11 is false. An equation may be true or it may be false. For our third example, 3x subtract 1 equals 8. Since we don't know what x is supposed to be, we don't know whether this statement is true or false. So in this case, we don't know. So an equation may be true, it may be false, or perhaps we just don't know. We have another definition now, which says a solution of an equation is a number that makes the equation true when substituted for the variable. A solution of an equation is a number that makes the equation true when substituted for the variable. So we're after true equations. For example, is -1 a solution of 3x subtract 1 is equal to 8? Remember, this is the equation that we had in our previous frame where we didn't know whether the equation was true or false. Now we're asked, is -1 a solution? Is -1 a number that makes the equation true when substituted for the variable? Well, let's find out. Now I'm going to show you a format that I recommend for working this type of problem. We begin by copying the equation, draw a line under the equation, and then draw a vertical line under the equals mark. We're going to separate into two parts. So it's sort of a T shape. Then we'll come down in the next line, and below the 3x subtract 1 we'll write 3. A set of parentheses where the x sits, subtract 1. On the right-hand side, we simply have 8, so we'll just copy the 8. Then in the parentheses, we'll fill in the number that we're trying out, the negative 1. So I'm going to put negative 1 here in the parentheses. This gives us an expression to simplify on the left-hand side and just a number on the right-hand side. So let's simplify. 3 times negative 1 is negative 3. Negative 3 subtract 1. On the right-hand side, we just have 8, so we continue copying it. Then negative 3 subtract 1 means negative 3 add negative 1. And that gives us negative 4. On the right, we have 8. Now, the two numbers, negative 4 and 8, are not the same. And so, I'll put a cross mark there. Those numbers are not the same. Is negative 1 a solution? No. Let's look at another example. This one says, is negative 4 a solution of x to the 4th power is equal to 16x squared? Well, once again, I'll copy the equation, draw a line under it, and then make my T-shape. So let's make the T-shape by putting the vertical line under the equals mark. On the left-hand side, I do have an x expression, so I'll put a set of parentheses for that. Copy the rest. Same thing on the right. So I have parentheses to the 4th power, 16 parentheses to the 2nd power. The number I'm checking is negative 4, so I'm going to fill in negative 4 in the parentheses in each case. That gives me an expression to simplify on the left. Negative 4 to the 4th power means negative 4 times negative 4, which is 16, times negative 4, which is negative 64, times another negative 4, which is 256. On the right, I have multiplying and an exponent. I'll do the exponent first, of course. Negative 4 to the 2nd power is negative 4 times negative 4, which is 16. That gives me 16 times 16, which is 256. So the two numbers are the same. This one checks. Is negative 4 a solution of this equation? Yes. Now I'm giving you some exercises. First exercise, is 1/2 a solution of 5 subtract 6m equals 8? Copy the exercise on your paper, and then when you get all the exercises copied, stop the tape and work them. First one again, is 1/2 a solution of 5 subtract 6m equals 8? The second exercise, is 1 a solution of y to the 3rd power subtract 5y equals y squared, subtract 3y, subtract 2. Y to the 3rd power subtract 5y equals y squared, subtract 3y, subtract 2. After you get these copied down, stop the tape, work the problems, turn the tape back on, and I'll have the answers up. The two answers for these, the first exercise, no. The second exercise, yes. If you made mistakes on these, see if you can find the mistakes yourself. If you cannot, be sure to ask for help.